Hey, in this lesson we are going to learn how to draw chemical formulas of both ionic and covalent compounds. So first, just to review quick, these are the notes we took last Friday. I just wanted to go over those quick because all of this information is really foundational. In order to do this formula stuff that we're about to learn, you have to know how to do Lewis dot structures. The basic idea here was if I give you an element, you just go over to a periodic table and find that element. Whatever group it's in, that's how many valence electrons it is, and that's how many dots it should get. So that's why sodium got 1 dot. Nitrogen, on the other hand, was over here in group 15. That means it has 5 valence electrons. Remember, these ones over here, you subtract 10. So 15 minus 10 is 5 valence electrons for 5 dots. Okay, and then last Friday, the basic idea here was I told you that elements don't want to be stuck with this number of electrons. They all want to have 8. Okay, this was called the octet rule. When an element has 8 valence electrons, this is a more stable scenario for the atom. There are 2 ways for it to get that octet. One is they can share electrons with another element. So here's an example I made last Friday where 2 chlorine atoms get together. And you can see over here that chlorine has 7 valence electrons. So I drew 7 dots around each of these. 1, 2, 3, 4, 5, 6, 7, and then red ones for this one. And I noted that, hey, look, if you put them close together and you let them share these ones in the middle, now they have 8 around them. So this chlorine now has 7 red ones plus that 1 black one that it's sharing from the other chlorine. And this chlorine on the left has its 7 black electrons plus that 1 red one that it's sharing from the other chlorine. So this is called a covalent bond. They both get 8, they're both happy, and as long as they stay next to each other, that's good to go. Sometimes they share more. Oxygen, for example, has 6 on each oxygen because it's in group 16. So each oxygen would need 1, 2 more electrons to get to 8. So if each oxygen shares 2 electrons, then they'll get that. So here on the red one, you can see it has 2, 4, 6 red plus 2 more black is 8 total. And same thing on the other side, as long as they stay together, they're sharing those electrons in the middle and they get their octet rule satisfied. Covalent means shared valence. The other way that elements can get their octet rule satisfied is for one atom to donate electrons to the other. So here's chlorine again, has 7, needs 1 more electron. Sodium has 1 valence electron, so sodium could donate that 1 to chlorine. So the big question last Friday was, well, why would sodium do that? Well, here's a Bohr diagram of sodium with all of its electrons, and there's that 1 valence electron on the outside. And you can see that if sodium donates, that's going to leave a full valence shell underneath. So as soon as I get rid of that one, now underneath we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so sodium is happy with this as well. Sodium wants to donate 1 electron, chlorine wants to accept 1. That's happiness for them. Okay, that's called ionic bonding. Now, notice that in covalent, chlorine and chlorine, oxygen and oxygen, those are both nonmetals up here in the upper right corner. With ionic bonding, I have sodium on the left and chlorine on the right. Well, sodium is a metal. Remember, everything on the left side of the periodic table here is metals. This is the dividing line right there, the metalloids. Everything to the left of that is metal. Everything to the right in the corner there is nonmetals. Notice that hydrogen is also lit up, number 1. That's a nonmetal as well. So metals on the left, nonmetals on the right. When you have a metal donating to a nonmetal, that's always the way it goes with ionic. When you have 2 nonmetals sharing, that's always the way it goes with covalent bonding. So right away, just by looking at what elements you're dealing with, you can tell already what's going to happen. Okay, so that's a big key for today, and I'll go ahead and start a new page of notes so that we can get that in there. Okay, and then we'll try a couple practice problems so that you know actually what you're doing. Okay, so covalent, nonmetals only. You should get this in your notes as well. Sharing. Ionic. Metal plus nonmetal. The metal donates. Nonmetal accepts. Okay, so these two rules are really key to understanding what's about to happen here. So let's do a few examples. 1. I give you two elements, let's say rubidium and bromine. First question, is this nonmetals only, or is it a metal plus a nonmetal? We need to know whether this is ionic or covalent bonding. Let's check on rubidium is right there. Now rubidium is in the alkali metals. It's a metal, so that settles it right there. This is a metal plus a nonmetal. This is ionic. So we're going to have donating and accepting. And when you have donating and accepting, you'll notice the pictures are a little bit different. You show arrows to show that donating, and then with covalent you just put things next to each other so that they can share. That's what that looked like up here. The circles are actually not going to come into the new drawings. That was just something I put in there last Friday to make it obvious what was going on. Okay, so we got to figure out how many dots to put on each. Rubidium's in group 1, that's going to get 1 dot. Bromine is over here in group 17, that's going to get 7 dots. Here's rubidium's 1, bromine 1, 2, 3, 4, 5, 6, 7. Remember, the octet rule says that the metals, they want to get rid of everything they have so that they can get to the full shell underneath. And bromine wants to get one more to get to that 8. So this is already perfect. I'm just going to donate that one right there. And that drawing now is finished. Here is the new stuff. The formula. You've got one rubidium atom and one bromine atom. Formula is RbBr in that order. Have to use a capital R, capital B. The second letter here, that has to be a lowercase b, and the second letter there has to be a lowercase r. Has to be like that. Examples of what not to do. Don't do Br, Rb. You always put the metal first, then the non-metal, not the other way around. Don't screw up your capitals. Don't do this. I mean, it's really hard to tell, especially with these elements, because it's nothing but R's and B's, so you got to get that right. So there's a really simple example. Example 2. Let's have some more fun. What if now I have calcium instead, and I'll stick with bromine. Now let's take a look. Calcium, again, we have to check, is it two nonmetals or is it a metal plus a nonmetal? Well, calcium is a metal. It's an alkaline earth metal. That's in group 2, so calcium's going to have 2 dots. 1, 2, and bromine still has 7. I'm going to start to use some color here to make it more obvious when I'm writing my answer. So the question kind of is, what do we do? This is ionic still. Calcium's going to donate, but look, calcium has 2 to donate, but bromine only has a spot for 1. If I give 1 electron to bromine, now that has the octet rule. It has 8. It's happy. But calcium's not happy until it gives away everything. So when you run into this, all you need to do is draw more atoms. Should I draw another calcium or another bromine? You always want to draw the one on the opposite side where there's the need. Calcium has this 1 extra, so I need to draw another bromine over here, because this other bromine atom, that's going to accept that 1 extra electron from calcium, and I would draw an arrow from that electron right over to the hole waiting for it in the other bromine. Okay, so here's my drawing for example 2, still ionic, but you're starting to notice I've added a twist where we can add different atoms in order to make it work, make the formula work out. And this does happen, right? When you're doing chemistry and you mix calcium with bromine, it's not like you're dealing with one atom of each. You have a whole beaker full of bromine, trillions of atoms of bromine. So it's really no problem for two atoms to come and accept one electron each from calcium. Now that makes the formula a little bit more fun too. It's still going to be the same letters, CaBr. Okay. This time though, we have two bromine atoms, so we get a new thing called a subscript. Okay, that is a subscript. The subscript tells us how many bromine atoms there are. It does not tell me how many electrons bromine took. It doesn't tell, I don't put a 2 on calcium because it had 2 dots. The subscript means how many atoms. And that's all there is to it in that example. Basically, that's the idea. If I give you 2 atoms, you just build pictures of atoms all the way down until everything evens out. Sometimes they can get kind of interesting. Like let's say I take a barium, that's going to be 2 dots. And I want to put it with, say, phosphorus over here. Okay, phosphorus is in group 15. That has 5 dots. 1, 2, 3, 4, 5. Now, phosphorus wants 8, just like everything else with the octet rule. 5 plus 3 more makes 8. So phosphorus wants 3 more. It's like there are 3 holes here waiting for electrons, but barium only has 2 to give. So go ahead and donate those 2 from barium. Now this barium atom is happy, but this phosphorus atom is not happy because it doesn't have its 8 yet. So we'll go down here and draw another barium atom. Every barium atom has 2 electrons, valence electrons, because barium is in group 2. Have to draw it the same way. Okay, so now I have another barium atom. And my pen just ran out of batteries. I'll switch to the mouse here. So I can donate this electron to phosphorus. But that's not quite where I want to be either. You see, now my phosphorus atom is happy over here on the right. It's got 8 valence electrons. And this first barium atom is happy, but this second one isn't happy yet because it had 2 to donate. It hasn't donated them yet. So hopefully you guessed, we're going to go ahead and draw yet another phosphorus atom. So now you can see when I've added that other phosphorus, now I've got a spot for this extra electron to go. Now we're back in the same boat as we were originally. We've got 2 empty holes here that want to be filled because this phosphorus currently only has 6 valence electrons with that donation. So once again we're going to draw another barium. And now finally, after all that work, I've got 2 slots to fill here and 2 to donate. So now I can count to double check. 1, 2, 3, 4, 5, 6, 7, 8. And now everybody on the right has 8, and all the metals on the left have donated everything they have. That's finished. This is a finished Lewis dot structure. The formula: got some barium, got some phosphorus, 1, 2, 3 bariums, so that's a subscript 3 on the barium, 2 phosphorus, so that's a subscript 2 on the phosphorus. Okay, more examples of what not to do with these formulas. Don't start using coefficients. Don't put the subscripts in front. Subscripts go after. Again, don't do them backwards. Don't do P2BA3. That's no good. There are lots of examples of wrong ways to do it, but this is what you need. Okay, I probably shouldn't circle that in red. So, your homework. You're going to go into Schoology. I've created a new folder for you. It is Unit 4. Where's my page up key? Here we go. Unit 4, you'll see there's a lot of stuff in here that you can't see yet on my screen, but what you want to look for is this November 26th 9 ionic compounds homework. You are going to open up a file in there, and it's going to show you that you need to make 9 of these drawings that I just made with the formulas. Basically, what you're going to open up is this slide. Okay, you got to make all the compounds with potassium to begin with nitrogen, sulfur, and bromine. Then you got to do magnesium with nitrogen, sulfur, and bromine. And then you got to do aluminum with nitrogen, sulfur, and bromine. All of these are ionic. We're just focusing on one thing today. If this is too easy for you, I'd be happy to offer you some extra credit if you want it. And I'll just write those out right here. These are all covalent. The pictures are going to be different. You can go Google around about how to do things if you don't understand. But this is a great way to get some extra experience if you are bored after doing those ionic ones. This is CCl4. How about PCl3? And that's enough for now. So I hope this goes okay.